Hello everyone, welcome to Engineer. In this video, we'll be doing example number 5 for the calculation of capacity of a balancing reservoir. So, a duration of 2 million. So, population is given as 2 million, right? Okay. Population is given as 2 million. Population is equal to 2 million. Has a continuous water supply. The average demand of the city is 300 liter per capita, which is supplied as shown below. So, demand is 300 LPCD, right? And this is the consumption pattern. Water is supplied from the treatment plant at a uniform rate for all the 24 hours. Calculate the water capacity of balancing reservoir. So, here is the treatment plant. So, let's say this is the treatment plant and this is the reservoir. And this is the distribution system to the consumers. So the system is continuous, right? And here the system is continuous. This is the demand part and this is the supply part. Now in the demand part, this it is continuous system and it is given by what? This particular table, right? So how to calculate this from the particular table? If you see here, this 120 is for one person, right? 120 per capita, right? Liter per capita. So this is 20 liters per capita. So we need to calculate for this time frame, these time frames, and these all time frames. We need to calculate for 2 million people. So for 2 million people, it will be 120 into 2 million liter, right? Because 2 million people, it is in liters, and if we multiply by 2 million, it will be 2 million liter, right? Now, it will be 70 into 2 million liter. It will be 80 into 2 million liter. It will be 30 into 2 million liter. So, it will be 240 million liter. It will be, so this one is the further demand, right? Let's circle this. This will be 140 million liter, this will be 160 million liter, and this will be 60 million liter. Now, for the supply part, it is given that water is supplied from the treatment plant at a uniform rate for all the 24 hours. So, it is also continuous system. And it is supplied for 24 hours. So, for this, population is 2 million as well, and demand is 300 LPCD, right? Now, this 300 LPCD is multiplied by this population to get the actual demand. So, 300 into 2 million. So, it will be a million liter per day, right? So, it will be 600 million liter per day, right? Now, this particular 600 milliliter per day will be converted to million liter per hour because we have the time in hours. So demand will be 600 divided by 24, right? So it is 24-hour supply. So here you can see 24-hour supply. So it will be 600 by 24 is 25. It will be 25 million liter per hour. So we need to have these values and this particular values for the supply system, and this is for continuous system. Let's go. So if you see here, in the table, you can find the exact same time period range as in the table given, and the time hours are for the time periods. And consumption is given as 120, 70, 80, 30, 300. So this is the 120, 70, 80, and this is 30 LPCD. So this is in liters per capita, right? Now demand is, we can copy demand from here, 240, 140 here, 240, 140, 160 and 60. So it will be 240, 140. So this is not meter cube, this is million liter. Also here million liter, also here million liter, also here million liter, right? 140, 160 and 60, 160 and 60, right? And for the supply part, it will be 25 million liter per hour. So 25 into time, right? So 25 into 4 is 100, and 25 into 7 is 175, and 25 into 4 is again 100, and 25 into 9 is 225, right? Now for the surplus value, the surplus is given as when supply is greater than demand, right? And deficit demand is greater than supply. Now let's subtract for the first row. 240, demand is greater, right? So if demand is greater, it will be deficit. So it will be 240 minus 100, it will be 140. Now for the surplus part, second row, it will be 175 minus 140. Supply is greater, so it will be 35, right? And for the third row, it will be demand is greater, so it will be 60 here, 160 minus 100. And for the another last, it will be 225 minus 60, it will be 165 in the surplus part. So therefore the capacity of reservoir is, let's see. Now if you see here, if I go from here, let's say this is the only value I take, but is this the maximum value? No, it is not the maximum value of deficit, because if I come here, it will subtract by 140 minus 35, right? It will be 105. If I go here, 105, and if I come here, it will be plus 60, right? So it will be 165. So obviously, if I go from here to here, it will be 165. And so this is not the maximum value, so I need to go from here to here. So 140 minus 35 plus 60, right? So the answer is 165 million liter. Now let's do this particular question from another method as well. So this is the table, and you need to now for the demand part, let's say demand part is 240, 140, 160, 60. 240, 140, 160 and 60. And for the supply part, it will be 100, 175, 100, 175, and again 100 and 225, right? 225. So let's find the cumulative demand. So the first one is 240 itself, and 240 plus 140 for the next 380, and plus 160 it will be 540, and plus 60 it will be 600. And for the cumulative supply part, it will be 100 first, right? And then 100 plus 175, it will be 275. And it will be plus 100, 375. And for the next part, plus 225, it will be 600, right? Now let's find out cumulative surplus and cumulative deficit. For the cumulative surplus, we need to do the if the cumulative supply is greater than cumulative demand, and for the deficit is cumulative demand is greater than cumulative supply. So the first one, let's see. So we need to see this and this, right? So 240 into 240 minus 100, the first one demand is greater, so it will be 140 here in the deficit part, and here is nothing. And for the second part, it will be 380 minus 275, and it will be 105, right, in the deficit part. And again for another row, it will be 540 minus 375, it will be 165 here. And for the last part, it will be 600 minus 600, nothing. So here the capacity of the reservoir is found out by the formula maximum cumulative surplus plus maximum cumulative deficit. So in this case, total supply and total demand is not used because they are equal, right? So maximum cumulative surplus is nothing, right? So 0, and maximum cumulative deficit is 165, right? So our answer will be 165 million liter. So in the both the method, the answer is 165 million liter. So that's it. Thank you for watching.